I'd like to demonstrate the process of taking a volume that's stored on NFS and migrating it in an online fashion to SolidFire while using the KVM hypervisor. First, just to kind of show you the environment I'm working with here, I have just a single zone, single pod, two clusters. Now, I do have a Zen server cluster in the mix here, but for the sake of simplicity, just to get my system VMs off onto another system, I've placed all of my system VMs on that Zen server cluster. What we'll be focusing on here is the KVM cluster I have. In each of these two clusters, I have two hosts. Now over on primary storage, which I'll click on the View All button, we have a few of them. The bottom one, NFS-1, that is the one that's cluster-wide and aimed at the Zen server cluster. It's being used to run those system VMs. The ones we're more interested in for the purpose of this demo are the top two. NFS-2 is, as the name would indicate, it's NFS storage, and it's for cluster 2, which is my KVM cluster. Right now, this is hosting a root disk on the one and only virtual machine that I have running in my environment. What I'd like to do is port that disk from NFS to SolidFire while keeping the VM online. And if I switch over to the Instances tab, we can confirm here that I just have my one and only virtual machine. If I click on the name of this virtual machine, we can see under View Volumes, I just have its root disk. So this is the disk, and I'll click on its name. If I scroll to the bottom, we can see the storage is NFS2. So this is the disk that we'd like to move to the SolidFire system, and I'll go ahead and demonstrate that process in a moment. First, let me switch over to my KVM hosts. I'll click over here, and this is one of my two hosts. This is the one that's running the virtual machine, and if we click on it and click on Open, I'll go over to the informational area, and we can see its one and only virtual disk. And this area here that I'm semi-highlighting, this indicates that it's being stored on our NFS share. I'll exit out of here. Where I'd like to take this, and I'll switch over there now, is to this other KVM host. Now actually, the way this works, I'm really interested primarily in moving the root disk from one storage type to another. However, there is a constraint in the underlying software that we use for KVM in how we can do that. So I have to actually migrate the virtual machine at the same time as I online migrate its storage. So even though our ultimate goal is not really to move the virtual machine itself from one host to another, we just kind of have to do that as a byproduct of moving its storage online from one storage backend to another. To make this happen, we need to make use of the migrate virtual machine with volume CloudStack API command, and this is something we need to actually use from a product like CloudMonkey, where we have access to additional parameters of that API command that are not available through the standard CloudStack GUI. So I'm going to switch over here to my command line interface, and we can see as I highlight it, I'm using CloudMonkey. I'm using the migrate virtual machine with volume API command. For the virtual machine ID, I'm specifying the ID of our virtual machine. If I switch over to the CloudStack GUI, click on Instances, click on the name of my instance, scroll down to the bottom, that is this identifier. Now back to my command line interface. I want to move this virtual machine to another KVM host because, as I mentioned earlier, that's just something I have to do with the underlying command that we're making use of within libvirt. So I've specified the ID, and that goes all the way to over here, the ID of the host that I want to move our virtual machine to. Next is a collection, actually, let's see here, two parameters. There's the migrate to with the volume subparameter, and the migrate to with the subparameter pool. Those two parameters are what we cannot specify through the standard CloudStack GUI, and why we need to make use of a product like CloudMonkey to actually invoke this particular API command. So what we're doing here is we're saying we're going to specify some details. The high-level property is migrate to. Now we're going to say for one of my volumes of this virtual machine, and in this particular case, it only has one volume, the root volume. So the way I indicate the volume that I'm talking about in this case is just position 0. I'll go ahead and highlight that. So we have an array here, position 0. And then our volume subparameter is going to specify the UUID of the volume that we're interested in. So we can go over to the CloudStack GUI, storage, click on my one and only volume here, and I'll just go ahead and highlight it. This is the UUID of this particular volume. So that's what this particular piece of information is. Then we look at the migrate to parameter again, and once more specifying position 0 in this array. We're looking at the subparameter pool and then providing the UUID of the storage pool that we want to transfer that volume to. And I'll switch over to the CloudStack GUI, go down to Infrastructure, Primary Storage, View All, go to SF-1, and that is this which I'm highlighting, that is this UUID. So we have everything we need here specified for this particular command. If we had additional volumes on this particular virtual machine, we would specify them in a similar fashion, but with a an index here. I'll highlight the 0, and the index would be 1 for the next one. So you'd have a migrate to, and then index location 1 dot volume. And then you'd similarly have a migrate to index position 1 dot pool, and that would just go on for however many volumes and pools you have for that particular virtual machine that you're interested in moving its volumes to other primary storages. The part I should probably mention before I go ahead and execute this command is that, and I'll click on the CloudStack GUI, and we're back here taking a look at our target primary storage. Now in this particular case, this primary storage that we'd like to move our volume to is referred to as managed primary storage. So what we did when we first added this primary storage to CloudStack was I specified a particular number of bytes, and in this case, a particular number of IOPS that I want to give CloudStack permission to use from the underlying storage system that supports this primary storage. So in this case, it's a SolidFire cluster, which is a scale-out system. We start with 4 storage nodes, and then as you need to increase performance and/or capacity, you add on additional storage nodes. What I've done here is use CloudStack's managed storage capability to add primary storage to CloudStack that is not based on a pre-existing volume or a pre-existing share. This is actually just providing CloudStack with a number of bytes, and in this case, an amount of performance that it can use. So in this particular case, we have our root disk on NFS, and we'd like to move it to SolidFire. What will happen during this process is we will create a new SolidFire volume dynamically with the appropriate size, And then in the background, while the system, the VM, is online, we will migrate the data from the source volume on NFS to the target volume on SolidFire. And the idea here, and I'll switch over to the SolidFire GUI to demonstrate this. If I look, and I'll refresh this view, if I look at the SolidFire GUI right now, we see there are no volumes. This is a fairly fresh system. I've used it before, so we'll see the identifiers for the volumes don't start at 1. But this has been a system where I've wiped out all of the existing objects. There are no accounts, no volumes, no volume access groups. We're basically starting from scratch. Right now we don't have any volumes. We'll see once this process completes that we do have a new volume. That volume was created dynamically as part of this process. So now let's switch back to CloudMonkey and execute the command and make this happen. Switching back to my command line interface. The parameters are set. I'm just going to go ahead and hit the enter button. So we can see here that work is being performed. I'm going to switch over to the SolidFire GUI again. This is our old view. If I hit the refresh button, I would expect to see a volume, and I do. So it's got the name root-5, which is pulled from the volume that we are replacing. It's in a SolidFire account. All SolidFire volumes are put into an account. It's an account-based system similar to CloudStack. The access groups, this is our container that says the two KVM hosts have permission to access this particular volume. I have the correct size. And I have right now default values for my min, max, and burst IOPS because the source volume was on storage that did not provide those parameters. We can change those later. If I go over to Actions and look at View Details, in just a moment we should see some activity being displayed in the GUI, indicating that the data is being copied from the source to the target volume. So let's see here. I wonder if it's actually already complete. We might be complete. We are complete already. So not much to see there in that view because this process is completed. I'll just click on the Volumes tab again just to go back to this view. Now, if we go back to CloudMonkey, we can see that this process was completed successfully. Let's go over to our source KVM host, and let me click on it and log in. All right, so this was our source KVM host. We can see that the virtual machine that was running here before is not running here any longer. So this looks correct. I'll switch over to the target KVM host and log into this system and log into it with a correct password. There we go. Now we see we do have our virtual machine running over here. And I'm going to switch over and take a look at dev disk by path. Originally, if we did an ls-l, we saw that we just had a single device, SDA. It had 3 partitions, SDA 1, 2, and 5. What we're going to see here, if I run this again, is that, and I'll go ahead and do so, we have another device. This is the SolidFire volume that was created to store the data that was previously stored on NFS. So now we have reference within our KVM host to another device. And this is the device, as I mentioned a moment ago, that we recently created during this process so that we could store the contents of the root disk. Now let's go over to CloudStack. Switch over to the CloudStack GUI, instances, and we can see our virtual machine is still up and running. So this virtual machine was online and running while not only while the VM was being migrated from one host to another, which is a pretty standard feature that's been supported in CloudStack for a while, but more importantly, while we migrated online data from NFS to SolidFire. I'll go into the Quick View column, View Console, and then just go ahead and log in here. And again, try to enter in the proper information. There we are. Clear. I'm going to run fdisk-l. And we see we have our device. Now this is what would have shown up before had we taken a look at this while the root disk resided on NFS as well. We see this information now. We know because we have knowledge of the backend system that the supporting device is now on the SolidFire cluster with its own particular performance characteristics. Now let's go and take a look at the management server, which was actually housing the NFS share that had the root disk for this virtual machine on it originally. So let me switch back over there. And we can see originally this was my NFS share for that KVM cluster. It has a folder with HA information in it, heartbeat files. And it had two other files. So these are my QCOW2 files that basically contain the contents of my root disk originally. One of them, the one that's larger in size, is the template, and then the other one was the delta file, and the combination of the two contained the contents of my root disk on NFS for my virtual machine prior to the online storage migration. Now if I take a look, I'm going to go ahead and refresh this. We can see that only the 6E6E file remains. That is the template. The other one was deleted after the process of migrating the data from that file and also the necessary contents from the template. After that combined contents were moved to the SolidFire volume, we got rid of the delta file 34, starting with 34E21. So that all looks really good. Now, as we've seen before, and I'll switch back to the SolidFire GUI to show this again, we have everything here that was on that NFS root disk now on our SolidFire volume. We do have our performance at, in this case, pretty high values, 10,000 for the minimum IOPS, 20,000 for max, and 30,000 for burst. One of the things that you will probably want to do, and those numbers were actually drawn from default values that were provided when I added that SolidFire primary storage to CloudStack in the first place. It basically said, if you ever try to create a volume on the SolidFire system and don't provide performance characteristics, this is what to use. Now, I picked these high values because it would allow us to copy basically as fast as that NFS share could go over to the SolidFire volume. But after you've done that, it's entirely likely that you don't want this particular volume to have these exact performance characteristics. And so the next step, which we'll see in a moment, is to go and change the performance characteristics of this particular volume to something that you feel is appropriate for whatever the use of this volume is. Let's go back to our command window. I'm going to clear this out, and I'm going to run cloud monkey resize volume, providing the ID of the volume I'd like to resize, and I'll get that from the CloudStack GUI. With my virtual machine, I'll click on its name, go to View Volumes, click on the name of my one and only volume, grab its ID, copy that back to my command window, paste it in. And then all I need to do is specify the min IOPS, and maybe I'll just specify 500, and then the max IOPS. Let's do 1,000. So I have my volume ID, the minimum and the maximum IOPS. The burst will be determined by taking the maximum and multiplying it by a multiplier that was provided when I added that primary storage to CloudStack that was based on the SolidFire cluster, I selected the multiplier of 1.5. So we should expect when this command executes that our volume should be at 500 minimum, 1,000 maximum, and 1,500 burst. Let's go ahead and run this and check it out. And by the way, the virtual machine is up and running. We can change these performance characteristics without taking anything offline. So this all looks like it was successful. I'll go ahead and highlight the pertinent information in the output. Max IOPS at 1,000, min at 500. Now let's go over to my browser window, and we can see this is the root disk. Now these are the old parameters, and you're going to see there's nothing that CloudStack knew about for that. Yes, it was set to 10,000 and 20,000 for min and max respectively on the SolidFire cluster, but that wasn't specified as part of the data for this volume in the volumes table. Now let's go ahead and refresh this information. There is actually a refresh button. I'll click on that. And we can scroll down, and now we can see we've got 500 minimum IOPS and 1,000 maximum. So that means the information is in the CloudStack database correctly in the volumes table. Let's go over to the SolidFire GUI. Now we can see the old information, 10,000, 20,000, 30,000. Let me hit the refresh button, and we should see 500, 1,000, and 1,500 respectively. And there we are, 500, 1,000, 1,500. So now we have the performance characteristics of this particular SolidFire volume, and therefore the root disk of our virtual machine set correctly. Now let's go back to the CloudStack GUI, and we can see if I go to the storage tab again, here's our root volume, scroll down, and here we are, it's on the SolidFire primary storage that we expected. A couple closing points to make. I don't actually have any volume snapshots on this particular root disk. I didn't before the migration, and I don't now. Now, I could have had standard volume snapshots before the online migration, and that would have worked just fine. We would still have access to those volume snapshots after the online storage migration, and those would still reside on secondary storage and be associated with this volume as you would expect. The interesting part here is that now that this is part of these, is being serviced by the SolidFire primary storage, any volume snapshots that we take from this point going forward will actually be stored on the SolidFire cluster as SolidFire snapshots. So that will be a very fast process. There is no taking that data and copying it to secondary storage. When you ask for a volume snapshot to be taken through the CloudStack API, which could be done through the GUI, through CloudMonkey, through whatever means you normally interact with the CloudStack system, that will actually translate into a SolidFire snapshot being taken on the SolidFire volume. So you'll have a very fast process of creating volume snapshots available to you. And that can be used from this point now going forward, even if we had existing volume snapshots that were created before the migration and were as such stored in the traditional fashion on secondary storage. So I just kind of wanted to point out that compatibility as well. So at this point, this wraps up what I had wanted to demonstrate here. Thank you very much for watching.